Hello students, welcome to an academy. This is your KP sir. So today our session is related to engineering hydrology for AE or AEE for any state government examination. Good evening Banu Prakash. So this is course of engineering hydrology for AE or AEE. Here in YouTube itself I am going to complete entire subject of engineering hydrology for any state government jobs. UPPSC, TSPSC, APPSC, TNPSC, MPSC, whatever your state government job. Whatever I am teaching on the YouTube for engineering hydrology that is more than enough for you. I will solve the theory as well as I am going to solve objective oriented questions of previous PSCs. So everything I will teach regarding engineering hydrology for state government examination clearly, because the students are messaging me regarding it whether it is sufficient for GATE and EAC. It is not at all sufficient for GATE and engineering service examination. Good evening Siva, good evening Sandeep Kumar. Good evening Prasad Royal, good evening Rahul. Students are continuously messaging me regarding whether this course is sufficient for GATE or IS. I have written clearly this course is not sufficient for GATE or IS. This course is only for AE or AEE. And from August 24th onwards in Unacademy platform I am teaching engineering hydrology. August 12th onwards in Unacademy Plus course I am teaching irrigation engineering. These are helpful for GATE and ESC. Listen carefully. If you want GATE and ESC full length course of irrigation engineering, 60 hours I am teaching irrigation engineering and also 60 hours I am teaching engineering hydrology. So total hydrology and irrigation combinedly I am going to teach 120 hours in plus course, paid course of Unacademy, which is helpful for your GATE and engineering services examination preparation. Don't feel that this course is sufficient for GATE and ESC. This is only required whatever content needed for AE and AEE only teaching here. This is not sufficient because I don't want to misguide you. Clear? I don't want to misguide you. This is only the standard level of the course of AE or AEE. This is not level of the course of GATE and ESC. So clearly listen everyone. Okay? TSPSC, UPPSC, APPSC, MPSC, whatever your state government exam, this course is sufficient. If you want for GATE and ESC, you take plus subscription in Unacademy. Before August 24th, engineering hydrology I am going to start. So take plus subscription of GATE and ESC in Unacademy. Good evening Fanishri. Good evening Rukshar Bano. So we'll move ahead to studying about our regular topic. So yesterday we discussed about types of rain gauges, recording and non-recording rain gauges, and also I have provided you Indian standard theoretical number of rain gauges. Now numerically how you estimate number of rain gauges required. Number of rain gauges required. For example, there is a rain gauge network in a specific area. There is a rain gauge network containing 5 rain gauges. In that area, will these 5 rain gauges are sufficient or not sufficient? How can we say? Can you decide number of rain gauges depending upon type of area? Plain area, deep forest area, hilly area. Can you decide depending upon type of area, or can you decide depending upon depth of rainfall provided? If you take plain areas in Western Rajasthan and plain areas in Assam, will same 1 rain gauge for 520 km square. Is it okay? Will it measure effectively? You understand my point? Plain area in Western Rajasthan 520 km square, plain area of Assam 520 km square. I have provided 1 rain gauge. Will it effectively measures it? Will it effectively measures it? Because Assam is a most wettest state in the country. Western Rajasthan is most driest place. We can't measure with the same number of rain gauges. No? So, number of rain gauges required is not depending upon the area. It is depending upon depth of rainfall occurred. It is depending upon depth of rainfall occurred in that region. The region where you are going to consider depth of rainfall occurred in that region. Number of rain gauges required, estimation depending upon depth of rainfall occurred at that specific location. For example, we have 5 rain gauges. So they measured the 5 rain gauges. They have measured rainfall values P1, P2. We'll write down like this. So 5 values of precipitation. Here there are 5 rain gauges existing, and they measured the rainfall values P1, P2, P3, P4, P5. Whether that 5 rain gauges are sufficient, more than sufficient, or less than sufficient, will decide by some procedure. First step in the procedure, estimate average precipitation. By taking already available values, you are taking already available values, just a simple mean calculation. P1 plus P2 plus P3 plus P4 plus P5, 5 rain gauges, divided by N. N is the number of rain gauges. N is equal to 5 here. Because we have written in the beginning itself 5 rain gauges. Good evening, Arjak. So, sum of given precipitation values. It may be Pn, you take number of precipitation, sum of given precipitation values by number of precipitation values, P average. Then estimate standard deviation. Estimate standard deviation, sigma. Estimate standard deviation. How can you get standard deviation? Under the root of summation of P minus P average whole square divided by N minus 1. Under the root of summation of P minus P average whole square. Means how can you take? You are taking like this. P1 minus P average whole square. P2 minus P average whole square. And so on. You continued up to last rain gauge station. last rain gas. For example, 5. P5 minus P average whole square. Yes, clear? Summation of precipitation minus average precipitation whole square. So you are getting some values. You are adding up all the values. That the sum is taken here. Summation of P minus P average whole square by N minus 1. N is number of rain gas stations. Number of rain gas stations. Then after getting P average and standard deviation. Completed your writing? Shall we move on? Finished your writing. So step 1, mean precipitation, simple mean or arithmetic average of precipitation. Step 2 is a standard deviation of precipitation. We'll move ahead. The standard deviation, then step 3, step 3. So we are going to write down step 3. Percentage of coefficient of variation. Step 3. We are determining percentage of coefficient of variation. So what is percentage of coefficient of variation? CV percentage. CV percentage is equal to standard deviation divided by average precipitation into 100. Standard deviation divided by average precipitation into 100. That is percentage of coefficient of variation. Hello Vijay. Then after getting, just assume some value. Percentage of error. Because wherever you are calculating, this percentage is not 100% accurate. Always you get some percentage of error. Restrict the error percentage between 5 to 10%, not more than 10. Here, restrict the error percentage to just 5 to 10%. Don't take more than 10% of error. So even though you are numerically calculating, 100% accuracy don't expect anywhere. Okay. Now, number of total rain gas stations required, or sometimes they will ask you number of optimum rain gas stations required. N total, N total or N optimum. What we can write down? CV by E whole square. CV by E whole square. Percentage of coefficient of variation divided by percentage of error whole square. These are optimum number of stations required. You understand? For effective measurement of precipitation with this mentioned percentage of error. For determining optimum number of stations with the given percentage of error, how many optimum stations required? These are the number of optimum stations required. After this, number of additional stations required. So already how many you are having? For example, we have taken 5. Na? You estimated total required is 12. How many additional required? In the beginning, what we have taken? 5 rain gauge stations are existing. Finally, you got N optimum. For example, we are taking. Finally, you got N optimum or N total 12. N total is 12. Then N existing is already given. N existing 5. So, with the existing network, how many new you can add? N additional. How many new you can add? N additional. 12 minus 5, 7. Is it not? 12 12 minus 5, it is 7. N additional. 12 minus 5, 7. So what is the formula here? N total minus N existing. N total minus N existing. So your numerical question, mostly for AE or AEE, they won't ask. By chance, if they have been asked, then your numerical question is estimate optimum number of stations required or estimate additional number of stations required. Any one is provided to you. Clear? This is the procedure to estimate optimum number. Here also you can write down optimum number of stations required. Optimum number of stations. So first you are estimating optimum, then you are estimating additional stations. So clear, we'll move ahead. We'll move ahead. I will write down a question for you. Till now there is no question on this in AE or AEE. By chance, if they have given the most easiest model only they will provide, they won't provide you typical model. Okay. Till now no such kind of questions related to N total, N additional. But by chance they have provided. They will provide you simple and easy questions. So that simple and easy we are observing now. A rain gauge network. A rain gauge network of 7 rain gauge stations. So I told you yesterday also RG. RG is rain gauge station. It is not RGV. It is not Ram Gopal Verma. Okay. Don't take RGV. It is RG, rain gauge station, rain gauge network. A rain gauge network of 7 rain gauge stations with coefficient of variation, percentage of 30 and allowable error of 10%. Estimate additional rain gauge stations required. Estimate additional rain gauge stations required. This is the answer. Simple now. CV is provided, coefficient of variation 30%, error is provided 10%. So N total, first we are estimating N total. CV 30 divided by 10 whole square. So N total is 9. N total is 9. So N additional. This N additional 9 minus 7 is equal to 2. So is there any difficulty in this model of question now? Do you need any kind of calculator, calci to perform it? Simple model of question. Clear, very simple model of question you are having here. So only this much simplicity questions only. This much simple, easy questions only they will provide to you. Coefficient of variation 30%, error 10%. Simple, 30 by 10 whole square. 9 n total. N additional. 9 minus 7, 2. Shall we solve one more question? Shall we solve one more question? A rain gauge network for a district. A rain gauge network for a district comprises 12 rain gauges. Average rainfall is found to be average rainfall is found to be 60 centimeter and standard deviation is 20 centimeter. This type in ESC is impossible, Banu Prakash. Don't expect that. If allowable error percentage is 5%. Allowable error percentage is 5%. Determine. What you need to determine? Optimum number of rain gauges required. Optimum number of rain gauges required. So, a rain gauge network for a district consists of a rain gauge network for a district consists of 12 rain gauges. 12. Directly they have given mean precipitation value 60 centimeter, standard deviation value 20 centimeter. Now allowable error also provided, which is given as 5%. Allowable error also provided, which is given as 5%. Determine optimum number of rain gauges required. So, solution. Now what we need first? First we need to derive coefficient of variation, standard deviation divided by average precipitation into 100. Standard deviation divided by average precipitation into 100. So it is value of coefficient of variation. What do you want? Coefficient of variation 33.33. Is it not? CV value what you are getting? 33.33%. Now N total, number of total rain gauge stations required. Number of total rain gauge stations required 33.33 divided by 5 whole square. 33.33 divided by 5 whole square. This is the answer 45. You will get something 44 point some value, some decimal value. So we'll take approximated and equalize it to higher value. So we'll consider it as a 45. Here 44 point something, some decimal value will get. We'll approximate it to nearby higher value. So that is taken as a 45 number of stations. Do we need to subtract here with 12? Shall we take 45 minus 12? Shall we take 45 minus 12? Yes, 44.43. So we'll round off to 45. 44.43 will round off to 45. Question is regarding optimum number of stations only. It is not about additional stations. Question is not about additional stations. So not required. Clear? Question is about optimum number of rain gauges only. So no need to consider. So we'll just consider total or optimum number of stations only. Okay, we'll move ahead. Missing rainfall data determination. Missing rainfall data determination. So what rainfall occurred, but unfortunately, here rainfall is happened at certain location, but unfortunately measurement of rainfall is not happened. Estimation of rainfall is not happened. Maybe due to absence of observer, maybe rain gauge station not working, or overflow of water had been takes place. So some reason, due to some reason, unfortunately, rainfall data is not measured. For example, in a September month, there are 10 days rainfall takes place, but unfortunately, September month data we are unable to estimate. All remaining 11 months data is there, but September month data is missing. So in such a case, so with some technical procedure, not voluntarily giving some value, instead of that, doing some technical procedure, we can solve it. That the technical procedure, first one. So that technical procedure, before going to the method, to start that technical calculations, we need to select some base stations. What are base stations? Consider the station with missing data, missing rainfall data. The station with missing rainfall data. This is called station X. Clear? Missing rainfall data is possible for station X. Now, the stations surrounding station X. Station means it is not railway station. It is not bus station. Rain gauge station. Remember carefully. It is a rain gauge station. It is not a railway station or bus station. Not a radio station. Rain gauge station. The rain gauge station with missing rainfall data is the station X. Now the rain gauge station surrounding rain gauge stations surrounding station X. Rain gauge stations surrounding station X with similarities. Not all surrounding stations we are taking, remember. Not all surrounding stations we are taking. With certain hydrological similarities, meteorological similarities, geographical similarities, all characteristic similarities. For example, station X is located here and stations A, B, C, D, E, F. These are surrounding station to station X. But station D is very close. But station D geometrically it is not similar to station X. We are not taking. Not because of closeness. Remember this. Not because of closeness we are taking, because of hydrological similarity, geometrical similarity, meteorological similarity. The properties are to be matched. So I got station A, station E, station C, which have similar characteristics of station X. So what are base stations now I selected? The stations which are similar to rain gauge station X, base stations I have selected A, C and E. Even though D and F are near to X, I have not selected. Good evening, Rudrajay Singh. You came late today. Good evening, Devi. You understand? Station D and station F are, even though they are very close, I have not selected because they are not a similarity. Hydrological, geometrical, meteorological similarity not possible. So only I have selected station A, C and E as base stations. You understand? Means station X is missing recording rainfall data in a month. On the same month, station A, station C, station E has recorded data. You got the point? Station X is missing estimating or recording rainfall data in the month of September. On the same month, rainfall happened for stations A, C or E. They recorded and values are available. So using rainfall values from base stations, precipitation values from base stations. Ranveer Pratap, D and F, they are not geometrically similar to station X. I told three similarities are very important, Ranveer Pratap. Geometrical similarity, hydrological similarity, meteorological similarity. D and F, according to me, D and F not showing geometrical similarity. Rejected. A, C and E are showing all the characteristic similarities, so I have selected. Very important, similarity with station X. Geometrical, hydrological and meteorological similarity. Okay, Rudrajay Singh. You understand now? So similarities are very important. Based on similarities, I have selected A, C and E. The values of rainfall for base stations considered. So I have noted. I am not taking now it as A, C and E. I have taken A as station 1, C as station 2, E as station 3. Base stations, BS. Base stations I have taken 1, 2, 3. So precipitation at base station 1, P1. Precipitation at station 2, P2. Precipitation at station 3, P3. Then what is precipitation at station X? Px. This is missing rainfall. Here, precipitation value at station X is a missing rainfall value. Precipitation at station X, Px, missing rainfall value. And recorded rainfall values, P1, P2, P3 for stations A, C and E. Now, first method what we are following? Simple mean method. Simple mean method. The first method we are following to estimate Px. To estimate Px. Simple mean method. Px is equal to P1 plus P2 plus P3. If number of base stations are more means you will add continuously. Pm divided by m. Good evening. If number of base stations are more, you add till Pm. M is the number of base stations. M is the number of base stations. So this is a simple arithmetic average, simple mean method, clearly written. Simple arithmetic average or simple mean method, which was clearly written. So sum of precipitation in the base stations divided by number of base stations. That will give simple mean method. So will the simple arithmetic average is an accurate method? Will it give? Simple arithmetic average or simple mean will give more accurate value? No. It is not provided. Simple mean is never providing accurate value. So we are going for most accurate method. Normal ratio method. Most accurate method. Normal ratio method. So what we are going for? Normal ratio method. We have the formula. Precipitation of station X is equal to normal annual rainfall of station X divided by number of base stations into P1 by N1 plus P2 by N2 plus P3 by N3 and so on. Pm by Nm. Okay, P values we know it. Precipitation, P means precipitation. Px is precipitation at station X. P1, P2, P3, P4 are precipitation values at missing time period for the stations 1, 2, 3 base stations, at the base stations. Then what is N? N1, N2, N3, etc. This is given as a normal annual rainfall. Normal annual rainfall of base stations. Very important. Normal annual rainfall of base stations. N1, N2, N3 and so on. They are considered as a normal annual rainfall of base stations. Yes, based on 30 years. Correct, Banu Prakash. Based on 30 years. What is Nx? Nx is normal annual rainfall of missing data containing station. What is missing data containing station? X. Nx is normal annual rainfall at station X. N1, N2, N3 is a normal annual rainfall of base stations. So this is a normal ratio method to find out missing rainfall record in a given location, at a given location. Okay. Only they will ask mostly for AE exam, they will ask the formula. The formula for normal ratio method. This is very, very important for you. Carefully write down the formula and by heart the formula. They will ask formula for normal ratio method. Mostly they won't give any numerical question. Okay. Okay, we'll move on. Average rainfall estimation. Previously, what we have estimated? Missing rainfall. Some rain gauge station not working for some time duration, we are estimating missing rainfall by simple mean and normal ratio. Okay. We have a river basin or a catchment. This is a river basin. So we are estimating average rainfall over a catchment. Average rainfall over a catchment or river basin. Estimation of average rainfall over a catchment or a river basin. This is a river basin consisting of rain gauge station A, rain gauge station B, rain gauge station C and rain gauge station D. 4 rain gauges. But individually each rain gauge has its own average annual rainfall. Rainfall for the entire year it is carrying. But I don't want individually for station. I want for the entire river basin average annual rainfall. Or for the entire river basin at a specific time annual rainfall, average rainfall. You understand it? Why it is necessary to estimate average rainfall? You take Godavari river basin. How long it is? It starts at Nasik of Maharashtra and ends at Antarvedi of Andhra Pradesh. So throughout this length of travel, several rain gauges are there. But I need for the year 2020 Godavari river basin average annual rainfall. Number of rain gauges are several. You got the point. Number of rain gauges are several. But I need for the whole Godavari river basin, here for the whole Godavari river basin, average annual rainfall. So for that we are estimating here precipitation over an area, average precipitation over an area. You understand the point? Why we are estimating average rainfall? If number of rain gauge stations are several, but that was covered by a single region, that a single region rainfall is estimated through average rainfall. That a single region rainfall is estimated using average rainfall. So for that average rainfall estimation, again first method. What is the first method? Arithmetic average method. Arithmetic average method. So simple arithmetic mean. Simple arithmetic mean or arithmetic average is determined. We need average precipitation value. We are taking P average. We need average precipitation value. We are taking P average is equal to number of rain gauges, their precipitation values. P1 plus P2 plus P3 and so on. Pn divided by n. Sum of precipitation values divided by number of variables. So what is n? Number of rain gauge stations available. Why here we are taking n and in the previous formula we are taking m? What is the reason? Here we are taking n. In the previous formula what we have taken? M. Why? What is the reason? Tell me. In the arithmetic mean method of average precipitation determination, n we have taken. In the simple mean or arithmetic mean method of missing rainfall data determination, we have considered m. Then what is the difference between m and n? Tell me anyone. What is the difference between m and n? M is considering base stations only, not considered total station. So what is total stations here? 1, 2, 3, 4, 5, 6, 7. 7 is the total stations. But we are considering only 3, A, C and E, 3 base stations only. We have not at all considered all 7 stations. But here how many number of stations are there? All stations considered, number of total stations. You got the point? In missing rainfall data, M is the number of base stations. In average precipitation determination, N is the number of total stations. Again, arithmetic mean method is not giving you proper value. Why? For example, station A is covering this distance. Station D is covering this distance. Station B is measuring rainfall from this region. Station C is measuring rainfall from this region. So what happened? What are these regions? What are lined regions? Lined regions are overlapping regions. Station A and C measures. Station A and D measures. Station D and B measures. Duplication of data. Is it not? Data is duplicated. No? For the same region, rain gauge station A is measuring, rain gauge station C is measuring. For the same station, rain gauge station A is measuring, rain gauge station D is measuring. For the same region, rain gauge station D is measuring, B is measuring. And very importantly, what we have? What we have here? What is this? Uncovered. This is uncovered, no? Uncovered. Not measured anything. No station is going to measure anything. Uncovered. No station is going to measure anything. So what about that rainfall in that region? Uncovered region. So arithmetic average not gives you accurate value. Is it not? Uncovered region are not providing, not estimated in arithmetic average. Because of that reason, whatever region we are having, whatever rain gauge stations we are having, we are dividing into number of polygons. This is a polygon for A, this is a polygon for A, this is polygon for B, D, this is polygon for B, and this is polygon for C. So if I plot like this, second diagram, is there any uncovered regions? This is truly originally region A. This is truly originally region D. This is truly originally region B. This is truly originally region C. So any overlapped region? Any uncovered region? No, not at all happened. No overlapping, no uncovering. No overlapping and no uncoverage of regions. So this is we are estimating through Thyssen polygonal method. Thyssen polygonal method. A.H. Thyssen, the scientist who proposed this method, he is named as A.H. Thyssen, his name. So with his name, we have taken Thyssen polygonal method, and we are taking importance not only for precipitation, we are giving importance for area also. Clear? We are giving importance both precipitation and area covered by rain gauge station, both. Rainfall depth and area covered by that rainfall depth. So both are equally important. So we are estimating using weighted average method. Thyssen polygonal method is a weighted average method. Instead of arithmetic average, arithmetic mean. Instead of arithmetic mean, I am taking weighted mean, weighted average. So I will estimate P average is equal to P1A1 plus P2A2 plus P3A3 and so on. PNAN divided by total area A1 plus A2 plus A3 and so on AN. You understand now? P1A1 plus P2A2 plus P3A3 and so on PNAN by A1 plus A2 plus A3 and so on AN. We'll move ahead. So we are writing here again another mode formula, same formula, weighted average. We can write down like this. P average is equal to summation of Pi into AI divided by sum of areas, summation of AI. Summation of P average is equal to summation of PIAI by summation of AI. Again, I have another formula for you. P average is equal to P1 into A1 by A plus P2 into A2 by A plus and so on Pn into An by A. Pn into An by A. What is this? A1 by A, A2 by A, An by A? Individual area by total area. Ratio of individual area to total area. A1 by A, A2 by A, A3 by A and so on. These are called Thiessen weights. Thiessen weights. The ratio of individual area to total area. This ratio of individual area to total area, this is called Thiessen weights. Clear? This is called Thiessen weights. Very important point you need to remember here. Sum of Thiessen weights. Sum of Thiessen weights. What is the value? Sum of Thiessen weights is equal to, tell me any one of you. Sum of Thiessen weights is equal to, no answer from anyone. Very good, Banu. Only Banu Prakash is answering, no one is answering. What happened? Be active. This is afternoon time, everyone is getting sleep. No, don't be sleepy, give the answers. Sum of Thiessen weights is equal to, always equal to 1. A1 by A, A2 by A, A3 by A are called Thiessen weights. So we can write down like this. Thiessen weight 1, Thiessen weight 2, Thiessen weight 3 and so on, Thiessen weight n. But finally, sum of all Thiessen weights is equal to, sum of all Thiessen weights is equal to 1. So this is a Thiessen polygonal method, which is a weighted average method to estimate the average rainfall. Then we'll go ahead with the third method. This third method, isoheital method. Isoheital method of estimation of mean precipitation. Isoheital method of estimation of mean precipitation. So it is isoheight. the regions on river basin, the regions on river basin that measuring equal depth of rainfall. Regions on river basin measuring equal depth of rainfall. Those are called ISO heights. ISO height is an approximately equal depth of rainfall. Not exactly, not accurately, nearly equal. Here, nearly equal depth of rainfall. Regions on river basin which cover approximately equal depth of rainfall. That is called ISO height. ISO, same. ISO means same. Height, same depth. ISO height. The regions of river basin measuring equal depth of rainfall, that is called ISO height. For example, this is a river basin. Here we are having a depth of precipitation 10 mm. Here we are having depth of precipitation 9 mm. We are covering the both. So we are taking here average precipitation 9.5 mm. And here there is a depth of 11 mm. Here there is a depth of 10 mm. We are covering the both and take average precipitation 10.5. Then here we are having 12 mm. Here we are having 11 mm. Covering the entire, we are taking 11.5 mm. Like this, different lines on the river basin. Approximately nearly same depth of rainfall. So ISO height 1, ISO height 2, ISO height 3 we are taking. Now what we are estimating, average precipitation will take same. Same weighted average method. But instead of normal precipitation, what we are taking? Average. P1 plus P2 by 2 into A1. Isoheital precipitation 1 plus isoheital precipitation 2 by 2. This is isoheital precipitation 1. This is isoheital precipitation 2. 9 plus 10 by 2. What is the value? 9.5. 9.5 into A1. Same. Plus P2 plus P3 by 2. P3 plus P2 plus P3 by 2 into A2. Same will continue. Pn minus 1 plus Pn by 2 into An. Finally, all values divided by again weighted average. A1 plus A2 plus A3 and so on. An. The only difference what we are estimating, isoheital precipitation. Instead of normal precipitation, what we are taking? Isoheital precipitation. Average of nearby values of precipitation. Clear? Isoheital precipitation. How we can say? Isoheital. P1 plus P2 by 2, comma, P2 plus P3 by 2, P3 plus P4 by 2 and so on. These are taken as isoheital precipitation values. These are considered as isoheital precipitation values. Clear for everyone? Tomorrow we'll solve objective questions related to missing rainfall and average precipitation data. Tomorrow we'll solve missing rainfall and average precipitation data. Okay, clear for everyone? So tomorrow class at 4 p.m. hydrology for AE or AEE. Same time we are going ahead. 4 p.m. only we are going ahead tomorrow also. Okay, tomorrow class at 4 p.m. we are going ahead. Hydrology for AE or AEE. Those who want to join in WhatsApp group or Telegram group, 89859. Those who want to join in the WhatsApp group or Telegram group, The mobile number is 89859 Here, send your mobile number to my WhatsApp message. I will add you to the WhatsApp group and Telegram group. And in our Telegram group, every day we are conducting quiz, daily civil engineering technical quiz, which is very much helpful for AE A-double exams. Here, daily we are conducting technical quiz, which is helpful for AE A-double exams. So join in our Telegram group, join in the WhatsApp group. You will get materials and all those things, questions also you will get. And take plus subscription as early as possible, because tomorrow I am going to start irrigation engineering full length course in an academy, and again from 24th onwards I am starting hydrology. So both subjects combo you are going to get in this month. So take plus subscription in an academy as early as possible to get a complete knowledge of irrigation engineering and hydrology. I think you gone through my classes, you understand how I am teaching. So if you are not requiring, if you don't want plus subscription, at least if you like my teaching, you understand the subject, refer your friends who are preparing for GATE and ESC to take plus subscription with my code KP Civil. My code is KP Civil. The students will get 10% discount, free online test series, scanned copies of notes and material. So everything the students will get. Whatever support required for them to crack GATE and ESC, I will take care. 100%. If you join in a normal coaching center, no faculty will support you. Faculty will come, teach and go. But if you join in an academy, I will take responsibility for each and every class in an academy platform. Clear? That is my responsibility for syllabus completion, guidance, timetable making, everything I will take care. So join an academy plus subscription, use my code KP Civil, use my code KP Civil. So if you don't want, already have taken coaching, no problem. Refer your friends to join under my guidance. Here, refer your friends to join by take plus subscription. So if you have any doubt, you send message to my number 89859 Okay, I'm going to close the session. What is tomorrow's session? Tomorrow same time 4 p.m. we'll meet again. Here, tomorrow 4 p.m. we'll meet again, hydrology for AE or AAA. Thank you, one and all. Bye bye.